Here we have a more advanced application of angles of elevation, and this is the same for angles of depression. It's just important to where we find where the right angle triangles are, and of course where our horizontal is and where the angles are made between them. So here we have a surveyor who's using a piece of equipment to measure the angle of elevation. From a particular point A, he finds that angle of elevation to be 20 degrees. He walks 100 meters up to B and finds another angle of elevation. It's 40. And we're told the piece of equipment is 75 meters, or 0.75 of a meter. It's vertically above the ground. So it's important, we want to find the height of the tower from the ground. Where is the ground in this equation? We're told the ground's horizontal, but we're using this piece of equipment to measure the angle of elevation. So in fact, the angle of elevation is coming from here, which is a right angle to the ground. So the ground is, along this point here. There's our ground. So there's going to be this extra height that's going to come in to find the total height of the tower, because the tower right to the ground is going to be down here. But from our angles of elevation, we're just measuring a particular portion of our height. Okay, so we've got that in there at 0.75 meters. And we're told, the ground's horizontal, and that's why we can take this horizontal line up. So we got to work out our right angle triangles. That's what angles of elevation is all about. Our first right angle triangle, you can see if you bring it down to here, you map it out over to a piece of equipment and bring it up. There we have our 20 degrees. So you're going to have tan of 20 degrees. It's going to equal the opposite, which is h, over the adjacent, which is 100 meters plus x. It's going to be 100 plus x. And then your second right angle triangle, do it in a different color. It's going to be just in here. Okay, you're going to have your 40 degrees. So you're going to say tan 40 degrees. Again, it's going to be h over x. So now we've got to solve these two simultaneously. Well, what happens is we rearrange this to find x tan of 40 degrees equals h. And what we can do is we can sub this equation in for a value of h here and work out x. We're going to do that in the next slide. So I'm going to work through this as quickly as possible. So if we're told the tan of 20 equals h over x plus 100, we can then sub in. So we know tan 20 degrees. So sub in the value of h that we use from the other equation, which is x tan of 40 all over x plus 100. Then we've got to rearrange this. We'll bring that up. You will get the tan of 20 by x plus, plus 100 equals x tan of 40, multiply out them brackets of x tan 20 plus 100 tan 20 equals x tan of 40. And because we're just tight in time, I'm going to speed this on ahead. So just sped it up a little bit. All I did was continue to manipulate this equation, take the x value out, bring it over. You get x equals this here. Put in your values for that. You get two negatives, makes a positive. So the x value is 76.61 meters. So we know our value now for x down here. So we can sub this back in to find the value of h. We'll do that. So we've done that here. We said x tan of 40 equals h. Put in our value for x, gives us our value for h. So if we flick back, we now have this value for h, but to get the total height of the tower above the ground, we must add in our 0.75, which we've done here, which is approximately 65 meters. We look at our answers there, we had 65 and 76.6, which is what we had. Okay, and that's the example.